Hi, my name is Alain Boudreau and I'm a marketing manager in our Clock and Data Management business unit at ON Today we want to showcase a new device that we released in the OmniClock family. This device has an I2C SMBus interface that was not available on previous devices in this family. This device is suitable for many types of applications, including especially audio applications such as high-end wireless headphones and high-end car audio amplifiers. But in reality, this device is very flexible and suitable to any applications and many different markets. Here we're showing a screen of our Clock Cruiser software, which supports all 5 devices that we've released in the family. Initially, we released 2 devices in QFN 16 packages, one in a 1.8 volt supply and one in a 2.5, 3.3 volt supply. This device is a full-featured device supporting output-enabled pins and a full spread spectrum engine. Then we release devices in DFN8 package which have fewer pins and support fewer features. The device that we're featuring today is also in a QFN 16 package, but instead of having 2 configuration selection pins, those 2 pins are reused as an I2C SMBus interface. On this screen you see a detailed block diagram of our OmniClock device with I2C SMBus. On the left-hand side we see the input interface which can accommodate a crystal or a clock signal. The heart of the device is a PLL which supports spread spectrum. The spread spectrum engine is fully programmable, allowing you to configure deviation and modulation rate to whatever suits your application. On the right-hand side we see 3 fully programmable outputs. We can use these outputs as 3 single-ended outputs, or we can combine 2 of the single-ended outputs into 1 differential output and 1 single-ended output, so the device can have a differential output and a single-ended output. With the differential outputs, we support LV-PECL, LVDS, CML, and HCSL. On the top, in the previous versions, we used to have 2 configuration select pins. In this device, we have I2C SMBus interface. Otherwise, in this device, we also allow you to program internal crystal load capacitors, and we also allow you to program output drive strengths for single-ended outputs. The initial 2 devices that we released in QFN 16 were one-time programmable devices. Those devices had 2 configuration select pins, allowing you to define and choose between 4 configurations. So in this case, those 4 configurations could be loaded into the device registers as required. The next 2 devices that we released in DFN8 did not have configuration selection pins, so we could only support 1 configuration on those devices. So that configuration gets loaded into the registers. This latest release device, the OmniClock with I2C SMBus interface, does not have any configuration selection pins. Nevertheless, we can still program 1 configuration into one-time programmable memory. Then, using the I2C SMBus interface, we can load as many configurations as we want that were previously saved to a local storage. These configuration files have to be created using our Clock Cruiser software and then stored into local storage. Then, using the I2C interface, we can load those into configuration registers. As a summary, the evaluation kit can be used with blank devices with our Clock Cruiser software to generate different configurations. Once the customer has settled on his final configuration, he can save that configuration to a file, send it to ON will create a custom part number, and then the customer can order devices using this custom part number.